Welcome, ladies and gentlemen, to 9.3. Okay, so we are talking about geometric sequences today. So geometric sequences. So the word that goes in your blank there is geometric. Let's see if I can write. Oh my gosh. Handwriting is so bad. Luckily, you can see how to spell it right here. If you didn't already know. Because, yuck. Okay. So a geometric series is sequence. Series will come next after sequences. A geometric sequence is one where to get the next term, you multiply by the same thing each time. So we call that the common ratio. So if I have 2 and my common ratio is 3, then if 2 is my first term, okay, and the common ratio is 3, then to get the second term, I'm just going to multiply 2 times 3, so my second term is going to be 6. Then I would multiply that by 2, so my third term would be 12. No, I was multiplying by 3. Sorry. 2 times 3 is 6, times 3 is 18. So I'm multiplying by 3 each time. I started at 2. Sorry about that. Okay, so we're multiplying by the same thing each time. So it's kind of like an exponential in that way, right? Where we're multiplying by the same thing each time. So arithmetic sequences were like linear equations, and geometric sequences are like exponential equations. We're multiplying by the same thing each time. So let's look at what our recursive and explicit formulas are going to look like. So our recursive formula, of course, is going to have the first term as part of it. Remember, we always have the first term and then the formula, because we have to find the formula we have to have a term in order to find the next term. That's what recursive means. I have a term and I use that to find the next term. So my recursive formula, they use n plus 1 and n here. I'm going to do the same thing I did last time, where I'm going to change that to being n and n minus 1. It's not a big deal. It's not different. I just want it to be consistent with the explicit formula. So I don't want to confuse with which one's plus, which one's minus. I just want them both to be minus. So I'm going to write the recursive formula the way we did on the last one. So the recursive formula, of course, I'm going to know that A1 is some number A, which is our first term. So here's an example sequence, where A is our first term, and then any subsequent terms are going to be the previous term times R, that common ratio. So the common ratios are, so each time we're multiplying by R. So we have A, AR, AR squared, AR cubed, because every time we're just multiplying by R again. So that exponent is going to increase. So this is going to be our recursive formula, right? If we know what our first term was, then the next term is just always going to be multiplying by R. So to get term 2, I would multiply A times R. To get term 3, I would multiply term 2 by R. To get term 4, I'm going to multiply term 3 by R, right? It's the same thing, just over and over again. That's how recursive formulas work. So then my explicit formula is going to be that AN equals A, that original number, the first term, times R to the n minus 1. So notice, right, we're increasing the power each time, but on the first term, it's essentially R to the 0, right? Because R to the 0 is 1. So if the first term is R to the 0, then I need to subtract 1, because n here would be 1, right? So 1 minus 1 is 0. So that's where the n minus 1 comes from. And it continues to work throughout because we're just adding 1 to the exponent each time. Okay, so this is our recursive formula. This is our explicit formula, and we're going to be using that throughout the rest of this section. So get ready for that, and I will see you in the next video.